Okay, so in this video, what we're going to be doing is solving quadratic inequalities. And in order to solve quadratic inequalities, you do need to be able to factor. So once again, if you are struggling with factoring or don't know how to factor, make sure you go back a couple videos and check out how to factor. So we need to be able to factor quadratic expressions, and we also need to have an idea of how to solve quadratic equations, which is the previous video. I'll go ahead and show a link to that as well. Okay, so solving quadratic inequalities actually not very different from solving equations in the beginning, but then we use solving equations a little bit differently with inequalities. Okay, so for example, like let's say we have the quadratic inequality of 2x squared plus x minus 10 is less than or equal to 0. Okay, so just like with a quadratic equation, you want to have everything on one side of the equation and 0 on the other side. So in this case, we want everything on one side of the inequality and 0 on the other side of the inequality. So if there was like a 5 or a 2x or something like that on the other side of the inequality, make sure you bring that over. But in this case, it's already in standard form, which is what we want. Okay. And just like with quadratic equations, when we solve by factoring, we're going to have to go ahead and factor this side. Okay, and if we were to factor this side, we would get 2x plus 5 times x minus 2. Okay, so we have 2x plus 5 and x minus 2. If you want to, go ahead and pause the video, factor this by hand. This is the two factors that you would end up getting. Okay, so 2x plus 5 and x minus 2. Okay, and just like with quadratic equations, we would actually use a zero product property and set each of these equal to 0 and solve. So we would get x equals negative 5 halves and x equals 2. The only thing is, though, that this isn't an equation. This is an inequality. Okay, so inequalities are not going to have just like one or two answers. They're generally going to have an infinite number of solutions, but they're going to be in certain intervals. Okay, there's going to be certain stipulations in order for it to be an actual solution. Okay, so the way we use these numbers is actually a little bit different. Those aren't going to be our answers. However, that's going to be the numbers that kind of split up our intervals. So I'm actually going to go ahead. I'm going to put these solutions on the number line. I'm going to graph them on the number line. So I have negative 5 halves and positive 2. Those were the two solutions I would end up getting. But since it's an inequality, I have to think about what intervals the solution is going to lie. And since this is or equal to, that means I can be 0. So I'm going to go ahead. I'm going to put a closed circle on each of these values. Okay. And now what we got to do is we got to think about where the actual solutions are going to be. And to help us do that, I'm going to introduce what we call a sign table. Okay, a sign table is going to help us figure out where the solutions are going to be. Okay, so what I'm going to do is I'm going to set up the sign table. Okay, I'm going to put all of our factors on one side. I'm going to split this up just like these intervals. Okay, I'm going to split it up just like these intervals. Okay, now from here we have to talk about something. The reason we want everything on one side, the inequality, and 0 on the other side, is because now we can just go ahead and actually look at what this inequality is, and it's actually going to tell us what we want our numbers to be. If we want to be less than or equal to 0, that means we want our answers to be negative numbers. Think about it. Only negative numbers are less than or equal to 0. Okay? So what we're going to want to do is have answers that are negative. So when we plug in x values, so if I plugged in like some negative, like some random value of x, like let's say I plugged in like -1 for x, when this all came out, if I plug in -1 for x, I would want this left side of the inequality to be negative, because then that would be less than or equal to 0. And that's actually what the sign table ends up helping us do. It allows us to figure out where those values are. Okay, so We have 2x plus 5 and x minus 2, and we have these three intervals. Notice it's kind of split up here. It's going to be split up into all numbers less than negative 5 halves, all numbers in between negative 5 halves and 2, and all numbers greater than 2. Okay, that's where the intervals are kind of split up. So what we want to do is we want to pick out any test point. We want to pick out any test point, which is going to be any number, and we're going to want to plug it in for x and see what ends up happening. Okay, so for example, if I want to test out some number that is in this interval less than negative 5 halves, I can pick any number. I'm going to go ahead and pick number negative 10. Why not? Negative 10. Negative 10 would be in this interval here. That is less than negative 5 halves. Well, now what I got to do is I got to plug in negative 10 for x, and I want to figure out if these gives us positive or negative values. Well, think about it. If I plug in negative 10 for x, I'm going to have negative 20 plus 5. That's definitely going to get me a negative number. So I'm going to show that with a negative. Now, if I plugged in negative 10 for x here, that would be negative 10 minus 2. That is also going to be negative. Okay, and now what we do with this is we think about it. These two factors here are multiplying, so we also want to know what their product would end up being. Well, a negative times a negative ends up getting us a positive, so all the numbers in this interval here are actually going to get us positive answers. Okay, so if I plugged in negative 10 or negative 50 or negative 4 or negative 1000, no matter what, both of these factors here would become negative, which would multiply to a positive, which means this interval is positive here. And if I think about it, our inequality, we want to be less than or equal to 0, which means we want to be negative, so none of our answers are actually going to come from this interval here. Okay, so now I got to continue with that. So I need to pick out a new test point. I need to pick out a test point now that's in between negative 5 halves and 2. Like 0. 0 is in between these two numbers. Think about it. If I plugged in 0 for x, I would have 0 plus 5. Well, that's positive. And I would have 0 minus 2. Well, that's negative. And a positive times a negative is a negative. So this entire interval here would end up being negative. And that's actually what we want. We want our answers to be negative. So part of our answers are going to be in this region here. Part of our answers are going to be in this region here from negative 5 halves to positive 2. I could have plugged in 1, I could have plugged in negative 1, I could have plugged in 2/3. We would always end up getting a negative value from here. Go ahead, if you plugged in 0 here, we'd have 0 plus 0 minus 10. That is definitely less than or equal to 0. Okay, but we need to continue. We now need to test some number that's greater than 2. Any number you can test 3, 4, 10. I'm going to go ahead and test 100. Okay, if I were to plug in 100 for x, that would be 200 plus 5, that's definitely positive, and 100 minus 2, that's definitely positive, and a positive times a positive gets me a positive, so this interval would here be positive, okay, which means that's not going to be part of our answer, so our only solutions are going to come from in between negative 5 halves and 2. So we can write that, so that would be our graph of the solution. We can write it as an inequality where x is in between negative 5 halves and 2, since it's or equal to, it's or equal to, or we can write it in interval notation. Negative 5 halves with a bracket around it because we can be negative 5 halves as or equal to, comma 2. We can be 2, so we put a bracket around it, and this would be our answer in each notation, okay? So that is solving quadratic inequalities, okay? So what we're looking for is what the factors are, where that splits up our intervals, and then test to see if you want to be positive or negative, okay? I'm going to go ahead and just do one more problem. I'm going to run through this one a little quick. Okay, I don't want this video to go too long for you guys, but I do feel I want to go over another example. So let's say we had something like this. Let's say we had 3x squared minus 10x minus 8 is greater than 0, okay? Once again, make sure everything's on one side. In this case, it is. And then we're going to want to factor. What this would factor to is 3x plus 2 and x minus 4 is greater than 0. And once again, feel free to pause the video and factor this by hand. Make sure you get the same two factors, okay? And now, if I were to go ahead and set each of these equal to 0 and solve, I would end up getting negative 2/3 and positive 4. Okay, so those are the numbers that I'm going to put on my number line. Negative 2/3, oops, negative 2/3 and positive 4. And since this is not or equal to, I'd be putting an open circle on each of these, okay? And now if we think about it, if we want to be greater than 0, the only numbers that are greater than 0 are positive numbers. So we're going to want our answers to end up being positive. So now I can go ahead and set up our sign table. Okay, I can go ahead and set up our sign table. So I have factors of 3x plus 2 and x minus 4, and I'm multiplying them together. Okay, so if I think about this, I want to test out any number that's less than negative 2/3. Let me test out like negative 50. Okay, negative 50 would definitely be in this interval here. If I plug in negative 50, I'm going to have 3 times negative 50 plus 2. That's definitely going to get us a negative number. And negative 50 minus 4, that's definitely going to be a negative number. Negative times a negative, because remember these are multiplying here, and negative times a negative is a positive, so this interval here is positive. Then I can test some number out that's in between negative 2/3 and 4, like 0. And if I plug in 0, this would become 0 plus 2, which is positive. This would be 0 minus 4, which is negative. And a positive times a negative gets a negative. So this interval here would be negative. Then if I test out some number that's greater than 4, like, I don't know, 1,000. Okay, I would have 3,000 plus 2, that's definitely positive. 1,000 minus 4 is definitely positive. A positive times a positive gets me a positive. So this entire interval here is positive. Okay, and now this is where we look back. We wanted to be greater than 0. That means we wanted to be positive. Well, that occurs in the intervals here and here. So this is where our answers would be. So as an inequality, we would want x to be less than negative 2/3, or x can be greater than 4. Okay, so that would be our answer as an inequality in interval notation. That would be from negative infinity, because we're going from negative infinity up to negative 2/3, and we can't be negative 2/3 because it's not or equal to, so that gets a parenthesis. Or, so union, we start back up again at 4. We can't be 4 because it's not or equal to, so it gets a parenthesis, comma, and it goes all the way to infinity. So that would be our final answer, okay? So definitely make sure that we're practicing quadratic inequalities, okay? I'll probably go ahead and release another video with just a few more problems and make sure that we're really grasping this concept, because it is extremely important, because we're going to build on quadratic inequalities. Eventually, we're going to be talking about polynomial inequalities, rational inequalities, and these are going to be using the exact same skills, okay? So make sure we're practicing. If you need a little bit of extra help, make sure you check out the next video. We will be covering a few more examples, okay? Thank you again. Make sure we're practicing.